Let's look at pages 11 through 13 of this PACE 1130. And actually, page 11, I kind of introduced this to you before you did your checkup. But since that was maybe a couple days ago since you watched that video, let's just walk through this again. Remember, we had some problems up here where I said, what if we had log to the base something has to equal this, and you have to figure out the answer. Remember, the logarithm is the exponent. So in every case, we're asking, what exponent do I need to raise this base to in order to get this number? So log to the base 9 of 1, I'm asking 9 has to be raised to what exponent to get 1? Well, anything is going to equal 1 if you have an exponent of what? Did I hear you say 0? Good. Anything to the 0 power would equal 1. Now let's look at this one. Log to the base 100, we want it to equal 10. We're saying 100 raised to some exponent is going to equal the number 10? Well, we have to play a little mental gymnastics here. Think about the square root of 100. Would that equal 10? Yes. And if it's the square root of a number, what exponent do we have? We talked about this, I think, in the last PACE. So a square root would be the same as this being to the 1/2 power. So sometimes we can have a fraction as the exponent. So that's kind of a tricky one here. We're not getting a whole number. You might think the answer should be 2 because your brain automatically tries to take the 10 and say 10 to the second power equals 100, but you're going the wrong direction, okay? If the base is 100, then we're finding the half exponent, all right, which makes it the square root, and that's how we get the 10. All right, here's another tricky one. This is similar to one you have in homework, but it's not the same problem, but let's talk about it. Log to the base 7 to get the third root of 7. Well, let's first write this as 7 to the 1/3 power. Oh, now it should be obvious. We're saying, what exponent do I need to raise 7 to get 7 to the 1/3 power? 1/3, okay? Because the logarithm is the exponent. This is the base, and this is the same as this. So now that the base, now I have it in the form 7 as the base and an exponent of 1/3, then that means the answer is the fraction 1/3. All right, so that's to help you do page 11. Now let's talk about on the bottom, I think of page 12, or maybe it's 11, 12. Bottom of 12 through page 13 says that we can use logarithms to help us. And again, we're playing some mental gymnastics, just trying to exercise and stretch our brain in some ways that it otherwise would not be stretched, okay? So there's a shortcut. Instead of multiplying 27 times 81 and then going back and trying to figure out, you know, what exponent you'd have to raise 3 to get that humongous number, there's a shortcut. We can first find the log to the base 3 of the 27, I'm sorry. And then we're going to add. Since this is multiply, the rule is we'll add the answer to these two parts. Log to the base 3 of 81. So let's simplify. 3 raised to what exponent will give me 27? And the answer is 3. 3 raised to what exponent will give me 81? 3 times 3 times 3 times 3. So 4. And so the answer to this problem would be 7. Okay? And you can look at, they show the rule on page 12 at the bottom with all letters showing you the reason why this works or how it works. I'm just illustrating it for you. Maybe if you see the illustration with numbers and then you go back and look at the rule, it might make more sense. If we're dividing instead of adding, we subtract the log of this answer minus the log of this answer. So for this, I would solve by saying log to the base 7 of 343, and I'm going to subtract. Since this is divide, I'm going to subtract log to the base 7 of 49. Now, log to the base 7 of 49, you say 7 raised to what exponent? Because the logarithm is the exponent. 7 raised to what exponent is 49? And it is 2. You might not know that the exponent on 7 to get 343 is 3. But 49 times 7 is 343. Check me on that if you want to make sure. But all right, so let's. So the exponent is 3. So in this case, the answer works out to be 1. You say to Mr. Inger, what if I had simplified this first? What if I had taken 343 and divided by 49? What would I have? Think about it. You would have had log to the base 7 of 7, because 343 divided by 49 is the number 7. And so what exponent would you raise 7 to get 7 to the 1 power? And the answer is 1. So, that works, okay? This one's a little different rule. If we have this argument, is what they call this, raised to an exponent, what we do is we multiply this exponent out here times the answer to the rest of it. So it becomes 8 out front times log to the base 2 of the 32. So this is asking what exponent do I need to raise 2 to get 32? 2 times 2, 4 times 2 is 8, times 2 is 16, times 2 is 32. So it would be 5. So this becomes 8 times 5, because 5 is the answer to this part, and so the answer to the whole problem is 40. Okay? I think by thinking about just hearing me talk through these 3 examples, if you'll go back and read page 12, study the rule that they have with the variables, and then study the examples that they have, it should hopefully prepare you to be able to do the homework here on page 12 and 13.